Dear students, so in this audio, we will see what is the difference between ray optics, wave optics, and quantum optics. So optics can be classified into three categories: ray optics, wave optics, and quantum optics. So you may be knowing the basic terms in optics, that is reflection, refraction, polarization, interference, diffraction. So, and you know that light is having a dual nature. That is, light is nothing but a electromagnetic wave. At the same time, it has the particle nature. It can be considered as a stream of photon particles. So light has dual nature. It has wave nature also and particle nature also. So wave optics is the one where you completely consider the wave nature of the light waves to describe the phenomena. Suppose say polarization, diffraction, interference. The observed phenomena can be explained only by considering the wave nature. That is, what is the wavelength of the electromagnetic wave, what is the frequency, at what speed it's moving. So you need to consider the wave nature, then only you will be able to describe the observed phenomena. That is interference, diffraction, polarization. Then you say that those comes under wave optics category. Okay, so suppose we know that any wave while moving, if it faces any obstruction, there can be a diffraction. So bending of light at the edges is called diffraction, you know. So diffraction occurs. To occur the diffraction, the wavelength of the wave must be comparable to the size of the obstacle or object. Okay, so we know that light in the visible range, the wavelength is 400 nanometer to 700 nanometer. So you can say 0.4 micrometer to zero point 0.6 micrometer. So wavelength is very small. So you can consider the objects like mirror, lenses. Those sizes are very large compared to the wavelength of the light. So the image formed by a mirror due to reflection can be explained without considering the wave nature of the light, because that object is not going to make any diffraction because wavelength is very small compared to the object size. So diffraction is not going to occur. So the light will travel in a straight line only. So if at all diffraction occurs, you know that due to diffraction, a straight uh, passing light beam will become as a airy disk patterns due to diffraction. But if at all there is no diffraction, the light will travel in a straight line only. Okay, so in that case, so we can ignore the actual wave nature of the light to describe the reflection and the refractions. That is the observed phenomena, the image formed by the mirror, the image formed by the lenses. To describe that one, you can ignore actual wave nature of the light. Still, you will be able to describe the observed phenomena. So, those things, that is in simple terms, when you consider the wavelength of the light almost zero, you consider it compared to the object size is very low, then you approximate to zero itself. So it is not at all going to get diffracted by any object, because the object size also should be comparable to wavelength, then only the diffraction occurs. If lambda is zero, then no objects can diffract it. So it will pass through in a straight line. So you consider this approximation if you try to describe the observed phenomena in optics, then you call it as a ray optics. So you consider completely a wave nature of the light and describe it, then you say wave optics. You don't consider or you no need to consider the wave nature of the light, still you will be able to describe the observed phenomena, then you say it is ray optics is the one which is enough, it deals with the phenomena. So then what is quantum optics? So quantum optics is the one where you completely consider the particle nature of the light, that is quantum nature, photons. You don't consider, if at all a light is progressing through a medium, instead of saying wave is propagating, you say that photons are moving. So using that concept, if you try to explain the observed phenomena, then you say it is a quantum optics. So you know that well-known phenomena, photoelectric effect. So that can only be described or explained by using the quantum nature of the light. By using the wave nature, you will not be able to describe or explain the photoelectric effect, observed phenomena. So you need to consider the particle nature of the light, quantum phenomenon. Then you say that it is quantum optics. So you completely ignore the wave nature, ray optics. You completely consider the wave nature of the light. Then you say wave optics. You don't consider wave nature, but you need to consider the particle nature of the light. Then you say quantum optics.